All right, this is number 14 on the homework. I want to go over this just because I want to make sure we got enough time for the rest of the course. So here is 14. It's a toughie. It's in two parts. Let's do part A first. We've got this interesting relation here, just like a curl, and it's modeled by this, and it equals 0. So what we want to do is we want to find the tangent line at 4, 2, and 2, 4. So you can kind of tell that this is... it's got that symmetry right there on the y equals x function, so I can see that that's why these two are switched. So they're going to be kind of similar to each other here. But anyways, let's just find the tangent lines and see where they see how they would graph. So what we do is we want a tangent line. We know the point, so now we just need the slope, and that is 99% of our battle, is to find the slope. Now, if we just do this once, we'll actually get the equation for all of the slopes that we need. Okay, so we're going to drop that. That's dy dx minus 9, and then that's going to be the y plus x dy dx. Okay, and then we always take the derivative of the end there. It'd be 0. Okay, so it looks like we're going to have to distribute that 9, so we'll do that. Okay, hopefully you got at least this far. All right, and then we're going to keep the dy dx's on the left. We're going to move everything else to the right. And we're going to use this equation for part B. All right, negative 3x squared and then plus 9x. All right, and then we will factor that out. This guy is going to go in the denominator of the other one. Okay, and the order doesn't matter which one is which. This is going to be 3y squared minus 9x. Okay. All right, so looks like this guy is now all set. All we have to do now is find out the slope for both of these guys. We're going to go ahead and evaluate it at 2 locations. So let's just do this at the first one. We will write this twice. All right, we'll evaluate it first at 4, 2. And then we will evaluate this guy at 2, 4. All right, let me scroll, sorry. All right, so all we're doing is plugging in a 2 for the x, and we're going to make sure that we turn that y. This is a y. I knew both of them had an x and a y, so I lost the y there here. Okay, when we moved them over there, I changed them to a y. All right, that was probably bugging you for the last 5 minutes. All right, so let's go ahead and put these values in. 3, 4 for the x. 2. You didn't think I was going to fix it, did you? You thought, oh man, he's going to get it wrong. I don't even want to watch this video. And then look at that, huh? Found it. All right, so let's see. I punched this into my calculator maybe. I don't know. Just do it in your head. If you do it in your head, 4, 2, it looks like that's going to be 16 to negative 3 plus 18. Then we're going to get, that's going to be over, it's going to be 5 over 4. All right, and then we're going to do it again here. The switched around so that the 2, and then that's 4 over 3, that's 4, and that's going to be 2. All right, and that's just because of the way that I had written it. So they basically just kind of switched around. And let's see, 4 negative 12 plus 36 divided by, that's 16 times 3 minus 18. So it's, okay. Okay, so that's going to be 5 over 4. All right. So it looks like those are our 2 slopes, 2 separate lines. And so it looks like it would probably be kind of like that. Like that. All right. And so our tangent lines. So our first one would be like I don't know, the y 4, 2. Oops, let me scroll down here. All right, the y equals at 4, 2 would give us the 5 over 4, x minus 4, and then plus that 2. All right, and then the y at 2, 4, we'll take the other slope, and that's 4 over 5, and then we'll get that x minus 2 plus 4. That does not need parentheses. Okay? All right, that great AP question right there. So that requires a lot, meaning plenty of places for errors. Let's go to part B. So be careful. This says find the tangent, so find the vertical tangents. Okay, so you see there's very large spaces for you to do the problem, and you are a little nervous because you think it's going to be an epic problem. It's not as bad as what it would seem. We've actually already figured out the formula for the derivative. So what we want to do is to find the vertical tangent line. Means that I'm looking for a spot where dy dx actually has a 0 in the denominator. Okay? So I'm looking for that, and that's all that I need. If I can find those points, I will get the spot where there is a vertical tangent line. I don't need the equation. I just need where it happens. Okay? So in order to do that, what I'm going to do is I'm going to go back to my answer up here, and I'm actually just going to focus on the denominator. So that's 3y squared minus 9x. Remember, the formulas are the same here. We're just choosing different points. So I want, where does 3y squared minus 9x equal 0? Where does the denominator equal 0? So this means that I got to solve for this. All right? I can't do it. I've got two variables. So all that I can do is basically find out where this something I can substitute back into the original equation. All right? I'm going to have to go all the way up to the top, and then I'm going to have to solve for one of the variables. What I'm doing here is I'm finding the location where one of the variables is going to sub in to the other. Now, you're going to choose which variable you want to isolate. Choose the x because it's x to the first power. Here, you'd have to do a square root, and then you would have to take a plus or minus a square root all the way back to the original one, and it would be an absolute disaster. So, you want to pick the one that you can isolate easily. So, what I'm going to do is I'm going to put the 3y squared over here, all right, and I'm going to divide by 9. Okay, which means that x equals y to the second power over 3. All right, now this x is going back into the original equation. All right, and so what we're going to do is we're going to rewrite this guy as x to the third power plus y to the third. Okay, we're not subbing him out. Okay, and again, it's because I don't want to take the square root of y and have to do some extra work here. What I'm going to do is I'm going to take the the x out, and I'm going to replace it with this y to the third over 3. Y to the third over 3. Okay, now I just got to see where this takes me, and this is where our algebra skills really kind of come into place here. All right, we're already at 10 minutes, almost 10 minutes for this problem. It's a doozy. So let's go ahead and raise this. That's y to the 6th over 3 to the 3rd is 27 plus y to the 3rd minus, let's see, 9y to the 4th over 3 equals 0. All right, keep going. Simplify this. This is going to be divide that by 3. Okay. Okay, let's keep this going here. We want to, did I miss the, oh, it's y squared. That's y squared. So that should be 3. That should be 3. These guys are like terms. So that actually is negative 2. So y to the 6th over 27 minus 2y to the 3rd. And that has to equal 0. Okay, so what can we do? We can actually multiply everything by 27 because I hate to have this guy here. And it looks like I'm going to need a new sheet. And I'm now officially in the 10-minute mark. So let's go ahead and multiply all that by 27. 27 times 2 is 54. And 0 times 2 is just 0. All right, now we got to solve that guy. So what is that going to look like? Well, y to the 6th. You got to use everything, all your algebra skills. All you can do is factor. I see that there is a GCF, that is y to the 3rd power. All right, that's great because now I've got y to the 2nd minus 54 equals 0. Okay, now that's actually to the 3rd power, is that right? No, that would be multiplied. That would actually there. Yep, that'd have to be to the 3rd power. Okay, so what do? You've got two equations here. Y to the 3rd equals 0, and then y to the 3rd minus 54 equals 0. You want to solve both of these. That guy's just 0. Okay, now let's move that y over to the other side, or the negative 54 over to the other side. So now we're just going to say y equals the cube root of 54. What is 54? Cube root inside him is a 9 times 6. All right, 9 times 6, there's triple threes, 1, 2, 3. So it looks like we can take a 3 out and have a 2 left over. Okay, so it looks like there are two instances where my y-coordinate is actually going to have a vertical tangent line. Okay, so now what we have to do is we have to go and get the x-coordinate. Okay, so we got to take this guy, and they have to go back to a location where I know what x is. Now we already know that x equals y to the 2nd over 3. Okay, so he's coming back into the situation. And what we're going to do is we're going to plug this for y, and then we're going to get our x. Okay, so he came back. So it looks like my x-coordinate would be 0. So it looks like 0, 0 is 1 point. Okay. And the second point is when x has to equal, okay, that's point 1. And the second point is when we take 3 cubed root of 2, we've got to square it and then divide by 3. All right, well, what is that? Okay. Well, let's see here. Okay, so, okay. Looks like we're going to do 3 squared, and then the 2, square that, over 3. So that's 9. 9 and 3 is 1 and 3. So we got 3 times the cubed root of 2 squared. Well, if you remember how these work, you can actually put the 2 there if you'd like. So I guess you could just write 3, 4. Okay, or you could have written 3 times 2 to the 2 over 3. Okay, that is okay. But either way, I think I like this one a little cleaner. So we've got our x-coordinate is 3 cubed root of 4 and 3 cubed root of 2. All right, that is where the tangent lines happen. Oh, and 0, 0. So that would be like right here at 0, 0. I didn't draw this very well. And then right here, that's going to be right there at that point. Okay, that's what this represents. That represents this, and the 0, 0 represent there. It looks better on the picture that you have, but that's the exact number. Okay? Wow, what a problem. I hope you gave it your best effort possible.